Basically, we have these z-scores, and we're going to take situations where we can use a normal distribution, and then if we do that, then we're going to have this area in the tail. So if I have a 95% confidence interval, 95% on the inside, how much is on the outside? 5%. 5%. So, well, 5% on the outside. Of that 5%, because it's symmetric, half will be in the left tail, half will be in the right tail. Let me get you a picture. That'll be easier. Oh, this isn't long. Hold on a second. So here we have our sort of our usual ranges right in here. And then we have our unusual ranges out here. The z-scores that separate the usual area from the unusual area, those are what we call our critical values. Those are z-scores. Typically, we've approximated them with about 2. Does anyone remember that? We said like a z-score less than -2 or greater than +2 is unusual. So we've been using typical values of 2 for these critical values. But now we're going to be a little more specific from here on out. So again, our likely numbers inside here, unlikely out there. 95% on the inside means 5% on the outside. Our alpha over 2, half will be over here, half will be over there. And I'll show you, before we get that far, first of all, my alpha is a probability. So whenever you're talking about probabilities and normal distribution curves, alpha is the same thing as what?
Mean.
Is what?
Mean.
Nope.
Or wait, probability.
Probability is the same thing as
area under the curve?
area under the curve. So these are, alpha is an area. I'm sure you folks are aware of that. Area under the curve. So for example here, right, 95% confidence interval, like we said, 5% on the inside means 95% on the inside means 5% on the outside. And it's symmetric, so it's split perfectly in half. Half of 5% over here, 5% divided by 2, alpha divided by 2, 5% over there. So my alpha is sort of the rest of it. 95% on the inside, my alpha is 5%. If it was 90% on the inside, what's on the outside? Let's try it again. 90% on the inside, what's on the outside?
5%. Or 2.5 on each side.
Try it again. 90% on the inside, what's on the outside?
10%.
10%. My alpha is 10%. How much is in each tail? 5% in each tail. Does that make sense? 90% on the inside would be 10% on the outside, 5% on each tail. In this case, I have 95% on the inside, which means 5% on the outside, 2.5% in each tail. Okay. And remember, the critical value is the z-score that separates the inside from the outside. We've always used a z-score of 2, right, for 95%? Everyone on board with me? Because what's our general rule for unusual? Unusual is what?
5% or less.
5% or less. So 95% confidence interval means 5% on the outside. So we've been using 2. Really, it's 1.96. Our critical values are negative and positive and negative 1.96. So it's almost 2 because it's an approximation. We've been using the empirical rule, which is an approximation.
Yes.
Right, so it's about 2 standard deviations. It's about 95%. It's slightly off of that. It's really 1.96. Okay. So this is all stuff you know. It's all stuff that's sort of, things that we're familiar with. This table on the top of the next page is all of your critical values. For the exams and in class, these are the only ones you're going to need. You should star this, keep track of it, make sure you know it. For the homeworks, there might be a couple that are weird, and I'll show you how to use a program to search for those and find those online. But pretty much, for the exams, this is the only ones you folks are going to need. So if I have a 95% confidence interval, my alpha 95% on the inside, my alpha is what?
1.
Okay, maybe I'm not speaking clear enough. If it's a 95% confidence interval,
5%.
what's my alpha?
0.05.
5%. And then my critical value is 1.96. If I had a 90% confidence interval, what would be my alpha?
10%.
10%. Then what would be my critical value?
1.645.
Right, the one that matches up with that. Good. If I had a 99% confidence interval, what would be my alpha?
1%.
1%? Good. Make sure you folks are right on top of this because this is not hard, but if you don't get it, it's going to be big trouble, especially when we get to chapter 8. Sorry. And my critical value will be what?
2.575.
2.575. You might need to round this for the homeworks. I can't remember. We'll take a look at that later on. Okay. Ryan, go ahead and read for me.
When data from a simple random sample are used to estimate a population proportion, P, the margin of error denoted by E, is the maximum likely difference with probability of 1 minus alpha, such as 0.95, between the observed proportion of P hat and the true value of the population proportion P. Right.
So that's a fancy way of saying, if you kind of think it back on our example with Oakland Airport, right? And we said it was 40 minutes, and then we added 20 minutes, and we subtracted 20 minutes to get 20 to 60 minutes. What we added and subtracted was our E. So in this example we did, we used our error as 20 minutes. Right? It's the amount you're adding or subtracting from the mean to get your lower and upper limits. How do you find it? Just like this. So you're filling this into your sheet, right? Yeah. Filling it in right here. Filling in the blanks. Margin of error E. Also called the maximum error of the estimate. How do you find it? You take the critical value, the number of standard deviations that you want to go in either direction, and multiply it by square root of P hat Q hat over N, which is a standard deviation. This is our standard deviation for our population proportions. So this is how many, this is our z-score. Z-score. How many standard deviations we want. And this here is our standard deviation. So let me put this into your notes. Okay. The critical value is a z-score. Yeah, question?
Oh, I just said that.
Oh. All right. Here's some things you're going to want to write down. P or P naught. Sometimes it's called P naught also. P naught is the same thing as P. They're used interchangeably. Some people use P naught. Some people use P. They both mean your population proportion. You have P hat. That's your sample proportion. There's N, the number of people you sampled. E is your margin of error. That is how much you added or subtracted from the mean to get to where you got from. What you added or subtracted from the mean in order to get or the p hat to get your upper and lower limits. And your critical value, also known as Z alpha over 2. It's the z-score separating your area and the tail from the rest of the usual values. All right. Couple requirements. 1, sample has to be a simple random sample. 2, you have to fulfill all the conditions for a binomial. And 3, you have to have at least 5 successes and 5 failures. So that's a little addition in there. You can't have a really lopsided distribution. All right, so how do you find it? again, you take your statistic, your p hat, plus or minus your critical value times whatever the standard deviation for that statistic is. So in this case, square root of p hat q hat over n. You can think of it in this picture too, right? P hat minus your error, p hat plus your error. Where error is your critical value times the standard deviation. Right? So that's what we did before. We did 45 minutes. We did with means. We did 45 minutes minus 20 minutes, 45 minutes plus 20 minutes, and then that's how we got our lower and upper limits. So start with your best guess, and then add and subtract your error. It's written like this, right? Where you have the lower limit, p hat minus e, is less than p, which is less than the p hat, your p hat plus your error. Please note that what's inside is not p hat. I know what p hat is. I found it, right? What we're trying to find is p. We're trying to estimate what p is, what the population proportion is, because I don't know that, what the whole population is. I know what e is. All right, so in this case, if you remember the 2016 election, Clinton had 4 points above Trump. So if we just ignored all the rest of the candidates and just looked at the two of them, then p hat would be 52 points, 52%, sorry, with an error of 1.5%. So I take my 52%, I subtract 1.5%. I take 52% and I add 1.5%. What's in between here? So it's definitely not, it's not p hat, because it was p hat. Then all we're saying is 52% is between 50.5 and 3.5. And we all know that. That's like saying 3 is between 2 and 4. That doesn't give anybody any information. We know what p hat is, so that doesn't help us. What we're trying to estimate, what we're trying to guess is, the population. What everybody in the country is going to vote. P naught, or p. Does that make sense for folks? So we're trying to estimate what the whole country thinks. P naught, that's what goes inside of there, not p hat. You know p hat. You're trying to guess what p naught is. Good? It's a very common mistake people will make. You can also write it this way. P hat minus e, comma p hat plus e in parentheses. That's called interval notation. That's also a very, very common way of writing stuff. So you can also do it this way as well. Totally fine. Rounding off rule. Great. So now we're going to round the, I'm not telling you how many decimal places anymore. Now I want 3 sig figs. Who knows what a sig fig is? Significant digit. Okay, good. So question here is, how many sig figs do you think there are in this one? With your neighbors, how many do you think there are? 15 seconds, go.
Is 0?
The ones that like round it up to the next one. I don't know. Yeah, there's 4 of them. So I'm like,
Okay. All right, heads up. I'm going to give you the answer now, which you will need to use for the next two problems. First, to find sig figs, you go to the first non-zero number. The first non-zero number is 2. Start counting there. 1, 2, 3, 4, 5. There are 5 sig figs. Everybody on board? Yes. Great. How do I write this in scientific notation? It would be written like this. 2.1036 E negative 03. Has anybody seen that? Or times 10 to the negative 3. Has anybody seen this on your calculator? Yes. Look up. If not, you will see it in your calculator. How do you get from this back to the original number? This means move your decimal place over 3 times to make it smaller. So you're going to add 3 zeros in front of your 2, and the decimal place goes after the first 0. That's how we got this one here. We did 3 zeros, 1, 2, 3, decimal place going after the first zero. So, yeah. Go ahead.
Do you after your do you have to put 0 for your V?
You can just put 3.
Okay.
Here. I was just trying to match up with what you see in your calculator.
Got it.
Your calculator says 0, 3 usually.
Oh,
Yeah. So that's how you get from here to here. You just add this many zeros to the front. Decimal place goes after the first 0. That's the easy way of doing it. Okay. So now I want everybody to practice rounding. Try rounding this one to 3 sig figs. So 3 sig figs. Try rounding this number so it only has 3 sig figs. Everybody do it. Round it off so it has 3 sig figs. Try. If you're not writing something down, then that's trouble, right? Round it off to 3 sig figs. Check with your neighbors and see if they have the same thing you have. Zora, Savar, neighbors. Nabnor?
Yeah,
You check with your neighbors across the way.
First one is 4. Yeah, but it says the cheap one. There's the first one was 5.
All right, so I'm going to take a look at it.
From 3. For the first one, it's like 5.
All right. All right. Okay, hands up, everybody. We're going to go over it.
No, this is
I'm going to go the first non-zero.
3,
Quiet.
2, 1, 4.
First
2,
non-zero.
1, 0.
I'll wait till you're done, Zora.
Add 1.
Zora?
Yep.
Okay, let me go and do this. First non-zero. 1, 2, 3. That's 3 of them. I need to look at the next one to see whether I round up or down. Good? So here, 0.002136 is between 0.00211 and 0.00210. It's between those two. Everybody on board? Yes. This is below it. This is less than it. This is above it. So I'm going to look at the next one and decide whether to round down to this or round up to that one. Which one am I going to do?
Round down.
Round down, because the 3 is 4 or less. When the 3 is 4 or less, then when the next number is 4 or less, you round down. So this is going to be the answer here. This 0 is important because the 0 says it's accurate to that spot. It's not, if I did this, the next number could be 1, it could be 2, it could be 4, or it could be a whole bunch of things. But now I know it's accurate to that spot. Everybody on board? So when I say 3 sig figs, that's what we mean. Okay? Now try it out with the next one. I want to round the next one to 4 sig figs. Do it now. 4 sig figs. Do it.
It will be 2104. This is this we round down.
Do not be paper. Just write it down.
I was sleeping.
Write it down somewhere on your notes.
I almost crashed on the way.
Yeah, now give me some zeros in there, because that's a really big number. I would add 0, 0, 2, and that 0 should be in the same place.
Oh, I don't live in Mayfield. It's like
Yeah.
No, nobody said anything. I just think that my manager was talking about my coworker.
No, I'm just saying.
Everything today. Really intense conversation. I'm not sure. I'm gonna be nosy. I'm gonna ask the teacher who knows everything. Because I work with her tomorrow. and nobody else is like ever there at night. Like it's like I'm fine there, so like nobody's I do this like all the way out.
I'm out of here.
Yeah, sorry.
So I could probably have something in my car.
Before COVID, when I was like in high school, I had an entire staff. I got literally everything. I had all this.
All right, so here we have 1, 2, 3, 4. Y'all look at the next one. It's not whether round up or down. So let's take a look. I'm going to count them. At first non-zero. 1, 2, 3, 4. I'm going to stop there. I'm going to round to that spot. I need to look at the next one. Decide whether I'm going to round that up or down. This is either going to be a 3 or a 4, depending on what this is. Do you see what I'm saying? Is it closer to 2104 or closer to 2103? It's closer to 2104 because this is more than half. It's a 5 or more. So this is going to round it up to 0.002104. Questions? No. You want to check with your neighbors? Check it with your neighbors, or everybody kind of on board?